Bonjour, hello, and a very, very warm welcome to launch day. We are on the pad once again for our friends Kinéis, who are preparing to launch their fifth and final mission, completing a constellation of 25 Internet of Things satellites in low Earth orbit. Right now it is 2:12 p.m. local time, and we are just 18 minutes away from liftoff. Thank you so much for joining us as we go to space today. My name is Prachi Saknani.
And I'm Jess Hepworth, and we're joining you live just steps away from mission control for today's launch.
The view on your screen is of our Electron rocket standing tall at Launch Complex 1 in New Zealand. Today is our 62nd launch, 58 of which have taken place from one of the two pads at this very launch site.
Headed to space today are 5 satellites for French Internet of Things constellation operator Kinéis. They're tucked up inside the fairing right now, but before we encapsulated them inside the carbon composite nose cone that protects them from the forces and temperatures of launch, this is what they looked like.
Our very first launch for Kinéis lifted off last June during Flight 50, and now here we are at 12 launches and just 9 months later deploying their fifth and final mission. Jess, how cool is it that we started and completed the deployment of their entire constellation in less than a year?
Absolutely. And how cool is it that this constellation aims to connect any object from anywhere in the world and transmit useful data from these objects to users in near real time. The use cases span environmental monitoring, agriculture and logistics, disaster relief, and much more. Let's hear from the people who designed, built, and are now operating the constellation to learn about its exciting potential.
Kinéis is a French company based in Toulouse. They are satellite operators and global connectivity providers dedicated to the Internet of Things. Mountains, oceans, deserts, 85% of the planet has no network coverage. In 2020, Kinéis raised a large amount of 100 million euros to address this global issue. Today, the company is following through and will deploy a constellation of 25 nanosatellites that will enable it to connect to a multitude of objects anywhere on the planet in near real time. Kinéis is convinced that this transmission of information, made possible by satellite connectivity, will enable it to respond to crucial challenges for mankind, its activities, and its environment. On the environmental front, for example, Kinéis's connectivity can detect a fire outbreak in less than 15 minutes, thus considerably reducing the extent of the outbreak and reducing the loss of property and human life. The same goes for monitoring water levels to prevent flooding and use this dwindling resource. The applications are endless, whether for locating, monitoring, or alerting. Since its creation in 2018, Kinéis and its teams have been working with this objective in mind. Their 25 nanosatellites that weigh only 28 kilograms are real technological gems. The retractable UHF antenna that, for example, can hear a bird sing within a rock concert 650 kilometers from Earth. They have been fitted with thrusters to ensure they stay on track for their mission. Some even carry children's drawings. At the same time, Kinéis has deployed many ground stations worldwide and have a sovereign infrastructure to guarantee data transmission to its clients. Today is a very special moment for Kinéis. It will finally conclude the series of 5 launches, which began in summer of 2024. With this last launch, Kinéis completes its space mission of placing a constellation of 25 nanosatellites in orbit. This last rocket houses the final 5 and will bring the system's performance to 100%. At last, Kinéis can finally devote itself entirely to its mission, to connect your objects 24/7 anywhere on Earth. Looking forward to it.
Today's mission is called High 5, a nod to the fact that this is our 5th mission for Kinéis. However, each launch has had its own distinct name and personality.
First, we had No Time to Lose in recognition of Kinéis' home base in France. Next up was Kinéis Killed the Raid IoT Star, a fun little nod to the Internet of Things or IoT capability of the satellites. The third mission was ICE AIS Baby, which referenced the Automatic Identification System or AIS capabilities of the spacecraft. And our most recent mission for Kinéis before today was IoT for You and Me, once again a play on the Internet of Things theme. As we prepare to watch the 5th launch take place for Kinéis today, let's take a quick look back at those first 4 missions.
5, 4, 3, 2, 1. Liftoff.
We can't wait for constellation completion for Kinéis.
Right now, we are just over 12 minutes away from completing that constellation with the final Kinéis launch. But before we can get Electron in the air, we need the green light from operators in mission and range control. Each operator will call out green or go to confirm the system that they are responsible for is primed and ready for launch. Or if for any reason they need to hold or stand down, they'll call out a no-go. So what we're listening in for are goes across the board to indicate that we're progressing with the count. Let's listen in.
To all stations LD in Mission Core proceeding with go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
Go.
And LD sub.
LD sub is go.
Go, no-go sequence complete. We are T-minus 11 minutes, 16 seconds and counting. We are go for terminal count. Auto sequence start at T-minus 10 minutes, From this time, the three-word procedure is in effect.
And that's just what we like to hear, a sea of greens across the board.
Now, like our previous missions for Kinéis, today's launch opportunity is instantaneous, which means we need to lift off at the exact planned T0 to place the 5 satellites in their required orbits. If for any reason we need to delay today's launch, we won't have an opportunity to recycle and try today, but we'll have to come back tomorrow or the day after at the exact same time.
But, of course, that's the beauty of launching on Electron versus hitching a ride with a bunch of other spacecraft on a rideshare mission. This way, Kinéis has complete control over when they go to space and exactly where they are deployed in orbit. That is, assuming the weather plays ball, of course. Which, today, as you can see on your screens, it looks like it is, so we're progressing with the count.
GCLD in mission court.
LDGC.
GC, proceed with sequence 57, part terminal checks.
Copy sequence 57 and work. Stage 1 igniter pressures verified, hydraulic pressures verified. LDGC mission.
GCLD.
Pad terminal checks complete.
Copy.
Today's mission is headed to a 650-kilometer low Earth orbit, but we're no strangers to missions a little further away. In fact, more than 380,000 kilometers away. That's right, I'm talking about lunar missions. Some of you might remember the capstone mission we launched for NASA, which used an Electron rocket to reach LEO and a Photon spacecraft to conduct a translunar injection to send a satellite all the way to lunar orbit for the very first mission of the Artemis program. While more recently, our software, hardware, and people supported another moon landing. Let's hear from the team behind those missions to learn what it's like to play a role in lunar exploration.
The atmosphere in mission control is absolutely exhilarating. Planning a trajectory to the moon is not an easy task. Rocket Lab is in charge of a number of really important things. From the flight dynamics, which is the team that I lead, to the GNC, or the guidance, navigation, and control, the flight software, and the ground software. Each of these has a really crucial role. Planning a lunar trajectory is always very unique. It's highly specific to each mission. It's highly specific to each payload on the vehicle. And the best way that we can solve this is really just by communicating with all the teams. There's a lot of work that is done within each team, and each team is full of experts. The most important thing that we have to do is determine what is the end objective. So we effectively plan it backward, from where we want to be at a given time, all the way to the phasing orbits that we need to be in, to where the moon has to be in with respect to the Earth when we launch, and to when we plan each of the maneuvers in order to raise our apogee, which is the highest point in the Earth orbit, in order to intersect the moon at the right time and turn on the engines exactly at the right time within less than 100 milliseconds. Rocket Lab was involved in the capstone mission that delivered a microwave-sized spacecraft in a really cool orbit called an NRHO, and that allowed Rocket Lab to build this whole platform called the Lunar Photon that is radiation tolerant, that has all these really important features for deep space missions, that is really important for developing the future of the industry. Because it means that Rocket Lab can just go to a given customer and say, hey, we have a platform that's ready for you guys to go launch directly in deep space, and we know how to fly it. So there's less uncertainty, a lot of flight heritage, and it's something that the teams know how to fly.
That's 2 NASA lunar missions complete, but we are far from done when it comes to missions beyond low Earth orbit.
That's right. The two Escapade spacecraft we've built for NASA are awaiting launch to Mars to study the red planet's magnetosphere. And of course, our private mission to Venus is also progressing too. In fact, just recently, the heat shield for the Venus mission capsule was fit-checked at NASA's Ames Research Center in California. That mission is particularly exciting as it hopes to study Venus's clouds in search for microbial life living in the atmosphere. So, while rockets might be how we started and what we named the company after, these days it represents just a part of the exciting and innovative missions we're undertaking, thanks to our ever-growing capabilities as an end-to-end space company.
Speaking of that, Launch Complex 1 is playing host to its 58th launch today, with 4 other missions having taken place from Launch Complex 2 in Virginia. Today's liftoff is scheduled for just 5-ish minutes from now, and after liftoff, the journey to orbit takes about 9 minutes, with payload SEP happening around 55 minutes later. Here's a simplified snapshot of what that looks like.
Electron will move through a series of pre-programmed milestones that you see here, including max Q, main engine cutoff on the first stage separation between those first and second stages, ignition of the single vacuum-optimized Rutherford engine on the second stage, fairing jettison, second engine cutoff, and then kick stage separation ahead of payload deployment. We'll talk you through each of these milestones as they take place in flight, but for now, it's time to settle in to the final count.
Once we hit T-minus 2 minutes, Electron will take over control from the operators as part of an auto sequence. So all that's left to do is let Electron's 9 Rutherford engines ignite at T-minus 2 seconds for liftoff when that clock hits T0. Let's hand it over to the operators in mission control to listen in on that sequence.
LDG's in mission.
GCLE.
ECS is disabled, pad auto sequence is armed, pad is ready for launch.
Copy, thank you, GC. From now, there should be no red flags on your critical LCCs. Vicon LD in mission court.
LD Vicon.
Vicon, lock the auto sequence and confirm.
Locked.
And Vicon, confirm all flight computer ASCOs are green.
All flight computer ASCOs are green.
Copy, thank you, Vicon. We are called for auto sequence start at T-minus 2 minutes. LDs go for launch.
The vehicle is fully on internal power. FTS is green and enabled for flight.
LOX load is complete. System is in recirculation. anti-geysering is disabled.
Stage 1 and 2 tanks are pressed.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over. Stage 1 propulsion nominal.
High fives all around as our 60-second Electron lifts off and clears the pad at Launch Complex 1. Keep an eye out on those dials at the top of your screen there to see Electron's speed and altitude rapidly climb as we make our way to space once again. Right now, we're less than a minute, or just about a minute away from into flight, and that means we're not far away from max Q when Electron experiences maximum aerodynamic pressure. Let's listen in for that call out for mission control.
Cleared max Q.
You heard the call. Electron has successfully cleared max Q.
HVB discharge
We're now
nominal.
at just over 17 kilometers in altitude and traveling at over 2,500 kilometers an hour. In just a few moments, the 9 Rutherford engines on Electron's first stage will shut down, signaling the start of stage separation. The main body of Electron, made from carbon composite, will split into 2 parts. The first stage will head back to Earth, while the second stage, powered by its own Rutherford engine, will ignite and continue its journey to orbit. All of this happens in a matter of seconds, so let's stay tuned and listen for the updates.
Propulsion holding nominal. Stand by for MECO in roughly 30 seconds. seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we go, successful MECO, stage separation, and second stage ignition confirmed. Electron's second stage is now continuing the mission to orbit with those 5 Kinéis satellites attached to the kick stage and traveling at over 8,200 kilometers an hour. Very soon, the 2 halves of Electron's fairing will split and fall away, exposing the Kinéis satellites to space ahead of deployment. This is a process called fairing jettison, and it's coming up very soon, so let's keep an ear and an eye out.
Fairing jettison confirmed.
It's goodbye fairing and hello space for the final 5 Kinéis satellites integrated onto the kick stage's payload plate. We are now just over 3 minutes into flight with less than 6 minutes remaining in the second stage burn.
Discharge holding nominal.
All right, folks, let's turn our attention to the right side of our screens. What you're seeing there are the real-time propellant levels for our second stage. We've got the fuel and ox levels up displayed, and with the kerosene at about 73% and liquid oxygen about 73% as well remaining, it is a great sign that everything is functioning smoothly so far. Let's keep an eye on those numbers as we get closer to staging.
Stage 2 now travelling at over 11,000 kilometres an hour, with that nozzle glowing bright over 179 kilometres above Earth. A beautiful view from our onboard cameras here. How cool is space, right?
Oh, absolutely. That is always a treat. Now, when we first launched Electron, it took with it a few world firsts, including the unveiling of our 3D printed Rutherford engines. Instead of using a traditional gas turbine, the fuel pumps inside Rutherford are powered by electric motors, and those motors are powered by batteries.
During flight, we use up all the power in one set of batteries before switching to a fresh set. But rather than carry the dead weight of those spent batteries all the way to orbit, we jettison them to give us more available mass for customer spacecraft. The nifty little maneuver is called battery hot swap, and it's coming up next.
HVB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
You caught it on your screen there. Battery hot swap has been successful. The next major milestone will be SECO, or second engine cutoff, coming up in about 3 minutes. At that point, the Rutherford engine will throttle down before shutting off completely in preparation for kick stage separation. After that, it's all up to the kick stage after a coast period to deploy the payloads.
HVB discharge holding nominal. AFDS has saved.
Now's as good a time as any to remind you that there's more than just rockets in this lab. And if you want to have views like this be a part of your everyday, there's a place in space for you. Right now, we have roles in our machine shop teams, so if you have experience with 5-axis CNC machines, editing and programming, or experience in Siemens or NX, then we want to hear from you.
Visit rocketlabusa.com/careers and get in touch with our talent acquisition team as soon as you can.
Entered burnout detect mode.
Not long now until that second stage engine throttles down and shuts off ahead of kick stage separation. The stage operator in mission control will call it out across the nets, so keep an eye on the nozzle on your screen as it cools down.
SECO confirmed.
stage separation confirmed.
And there you have it. Electron's second stage Rutherford engine has shut down, and the kick stage has separated for the coast phase as planned. For the next 45 minutes, the kick stage will pass around Earth until it reaches a precise point where the tiny 3D printed Curie engine will ignite to raise the orbit ahead of payload deployment.
This phase is an important period where the spacecraft is essentially coasting through space, following its calculated trajectory without the need for engine burns. During this time, our team will be closely monitoring all systems to ensure everything is functioning smoothly and according to plan. This phase allows us to prepare for the critical moment of payload deployment, ensuring that the satellites are released into their intended orbit accurately and safely.
So while we wait, please sit tight and stay with us. We'll be back in approximately 45 minutes with live coverage of the payload deployment. In the meantime, feel free to grab a snack, stretch your legs, and we will see you back here soon.